Velkommen til webinaret her i DMN og Ensum regi. Vi er i dag så heldige, så vi har fået besøg af professor Alan Schoenfeldt, som er en af de store matematikdidaktikere vi har her i verden. Han har lavet utrolig meget forskning knyttet til læring og til assessment inden for matematik, og har modtaget indtil flere medaljer og priser for hans arbejde, og så vi tænker, at det kunne være rigtig interessant for jer at lytte lidt til hans arbejde. I dag kommer vi til at tale om det, han omtaler som powerful student learning. Welcome to you, Alan. I was just telling the audience who are listening and seeing our webinar that you're a very clever guy. So please welcome to you, and you can make your presentation.
Well, thank you very much, Bent. As my title says, my emphasis is on thinking about how to create the most powerful learning experiences for students so that they become knowledgeable, thoughtful, reflective, mathematical thinkers who feel good about themselves as doers of mathematics. And most of that action takes place in the classroom. That's why the title is focused on the classroom. So let me give you the basic idea of what the next half hour will be about, and then we'll turn to some questions after that. I come from the U.S. We have our own typical teaching style. We have our own curriculum. The Danish typical teaching style is consistent and somewhat different from the U.S. You have the competencies, we don't. There are some differences. But at the same time, across not only the U.S. and Denmark, but every nation I visited, there turn out to be some consistencies in classrooms where, when the right things happen, no matter what the language, no matter what the curriculum, students emerge being really powerful mathematical thinkers and problem solvers. And that's the main topic for today. What I'm going to wind up doing is summarizing those consistencies and then talking about two new books that help teachers develop and refine the kinds of powerful classrooms that we want to see that help students learn. So I'm about to distill 20 years of research and development into 3 slides. First is about our goal. What do we really want when we teach? I've already said it. Every student, and that's important. We don't want classrooms in which 3 students shine and the rest of the students don't seem to care or matter. We want every single student to have the potential to be someone who can think and act mathematically. And now I'm going to introduce a term that's not that common. Have a sense of mathematical agency or initiative. When you show some people a mathematics problem, their immediate reaction is to go, oh, I hate mathematics. You give a problem to someone else and they go, oh, that's cool, let's play with it. I can fiddle around with the mathematics. That's a sense of agency or initiative. It relates to a person's mathematical identity. The person who's afraid of it, who has math anxiety, is not going to engage with mathematics. And that's important not only inside the classroom, but outside the classroom as well. Many of the issues we deal with in democratic societies have mathematical underpinnings. Climate change, issues of equity. If you understand the mathematics behind them, then you can think about them. If you go, there's mathematics there, I don't want to think about it, you don't have access to democratic participation. So what we want is classrooms in which students learn a great deal of mathematical content. They learn a great deal of mathematical processes. That's conjecturing, proving, reasoning, questioning mathematically. All of those are part of mathematics, and they do it in a way that they feel comfortable and natural doing that. That's the goal. We want that for every single student. So now we get to the theoretical framework. True, T for teaching, R for robust or strong, U for understanding. Teaching for robust understanding. And the idea behind the theoretical framework is that there are 5 dimensions of classroom practice that matter. Okay? And those are the things you need to pay attention to. If those 5 things go well in the classroom, students will emerge as powerful mathematical thinkers. If there are problems with any one of them, then there will be problems. Either not all the students will learn, or they will not learn as much as we'd hope, or they won't have good senses of themselves mathematically. So what's critically important are these 5 dimensions. There are none there. Oops. Let's look at the first. That's the mathematics. Content and practices. I could only fit 2 words on the top. Every nation decides what's going to be important in mathematics in the curriculum. In the United States, we have the standards. In Denmark, you have the competencies. They begin to describe what's important. There's an awful lot in that box about the mathematics, the discipline of mathematics. It includes the things I mentioned before, not only knowing all the competencies, but in addition, being able to conjecture, being able to reason, being a flexible thinker, being able to do problem solving. All of those are part of what the student needs to experience in the classroom. And what happens is that what actually takes place in the classroom puts an upper limit on what the students are going to learn. If the mathematics is dull and rote, repetitive drill, the students will never have the opportunity to develop the skills of conjecturing, reasoning, proving, etc. So the content is clearly important. It's 1 dimension out of 5. 95% of the time people talk about mathematics classrooms, that's what they focus on. But it's 1 dimension out of 5. The next 4 are equally important, and they all relate to the student's experience in the classroom. The second dimension is called cognitive demand. That's jargon, and I hate it. So let me speak plain English, which I hope translates into plain Danish. The phrase I like to use is productive struggle. To learn, you have to work. There's no question about that. If things are too easy, if you just repeat the things you're told, you're not going to learn new content in meaningful ways. If things are too hard, you're lost. If you have to work, you have to figure things out, you have to make sense of them, and you do, then that becomes part of your knowledge in a powerful way. The term that we use that makes sense to me is productive struggle through sense-making. If you're doing sense-making, if you're struggling productively, then you put things together and you remember them. Okay, the metaphor for me is weightlifting. If I give you a 1-pound weight, you won't build any muscles. If I give you a 500-pound weight, you won't be able to lift it. You won't build any muscles. I have to give you the weight that's appropriate for you. Now, the problem is, in a classroom, different students know different things, need to be stretched in different ways. So part of the challenge of productive struggle is building the curriculum, building the tasks, building the conversations so that every single student can be stretched. And if you ask me at the end about a task and an example I have, I know which one I have in mind. Okay. The third dimension is equitable access. In a classroom, you could have beautiful mathematics, but if the teacher calls on the teacher's 3 favorite students and those students answer the questions, what about all the other students? They're not involved, they're not learning, they may be sitting in the classroom, to use a word that seems to be common. They're in the classroom, you have inclusion, but you don't have inclusion amounting to meaningful engagement with the important mathematics. So you need more than just inclusion, more than social inclusion, in order for students to become powerful mathematical thinkers. Every single student needs to be engaged with the core mathematical ideas. And it's more than just engagement. I often put dimensions 3 and 4, equitable access to the mathematics, and agency, ownership, and identity together. You know, before I went, there are people who go, oh, mathematics. Well, there are a lot of people who do that. Their mathematical identity is, I'm bad at mathematics, I want to avoid it as much as I can. Well, that's a very serious problem. And the question we have to ask is, where do students develop their mathematical identities? And the answer is, well, they may get some feedback from family and friends and society, but a large part of where they learn who they are mathematically takes place in the mathematics classroom. If you're the one that the others treat as not being very smart, you're going to walk out of that classroom thinking you're not very smart. If you're the one the teacher doesn't call on with a good question, then you internalize that. That becomes part of who you are mathematically. So part of a powerful mathematics classroom is one in which every student has the opportunity to contribute ideas. Those ideas become part of the classroom conversations. They comment on others' ideas and build on them. Others comment on theirs and build on them. And in the process of mathematical conversations, then everybody is involved and everybody has a chance to develop the sense that they can actually do mathematics. How do you develop the sense that you're a bike rider? You get on a bike and ride, and you're helped to do that. Some people get on and speed away right away. Others use training wheels and take a little longer. But everybody can learn to ride a bike, and then they see themselves as bike riders. It's the same thing for a sense of mathematics. Now, I'm going to go back and forth a little bit, because the question is, how do you do that? It helps if you have very rich and engaging mathematical tasks that can be solved a number of different ways. So suppose the 4 of us are in the room. There are the 2 of us talking here. There are 2 people behind the camera. Someone gives us a problem. If it's really interesting and there's a straightforward way to get into it, well, I'm not that good at my math. So I start that straightforward way and make a suggestion. The guy behind the camera over there is a math whiz. He says, what about doing it this way? And then we have to go, do they both get us to the same place? How does my solution relate to your solution? So rich tasks allow me I'm not very good at math, to dig in at my level of, guess what, cognitive demand, that's dimension 2, and build my sense of mathematics. The person who can really do sophisticated math gets to explain, that's an important mathematical competency, gets to talk with me and make the connections between their method and mine, building their own sense of mathematics. So the right tasks and the right supporting of dialogue allows everybody, that's equitable access, to engage with, I just told you, this is a rich math task, we're making connections. So all 4 of those things can happen. How do we make them happen? That's the 5th dimension called formative assessment. Formative assessment consists of the teacher, the environment, making student thinking public first, because you can't adjust to it. How can you know how to adjust a task so that there's the right level of struggle for a student if you don't know what the student's thinking? So there has to be student thinking out in the open, and then there have to be ways to ask questions. So-and-so said this, so-and-so said that. Are they agreeing or are they disagreeing? Sort that out between yourselves. What about the relation between this and that? Oh, you're struggling here? Why don't you think about this? Not, I'm going to give you the answer, but why don't you think about this? That little bit of structure may help you engage more deeply. So formative assessment is the tool for making sure that all of the other 4 dimensions work. The teacher makes sure the content is rich. If the students are off not thinking about big ideas, the teacher can ask, have you thought about such and such? The teacher can adjust cognitive demand by suggesting related tasks, making sure that everybody is involved in powerful conversations that build the sense of, I can contribute, that's agency. I solved this. It's not they told me to use this formula, it's I figured it out. That's ownership, and I'm a math person, I can do that stuff. Now, the only thing I have to add about formative assessment is the way I just described it, it sounds like I've made the job of the teacher impossible. It used to be, my job is, I explain the math beautifully, and then it's the student's responsibility to make sense of it. The term we use sometimes in medicine is the operation was a success, but the patient died. Okay. The change here is we'd like the patients to live, but it's not just the teacher's responsibility. We had we're partners with the Shell Center for Mathematics Education at the University of Nottingham, and they built some beautiful lessons called formative assessment lessons that have gorgeous, gorgeous problems in them. So when you're looking for rich tasks, go to the formative assessment lessons. And the lead designer, Malcolm Swan, was visiting us when a teacher came in who'd been using the formative assessment lessons. And she said, we have a thing called National Board for Professional Teaching Standards. She was nationally certified as an expert teacher. And she said, Malcolm, I don't know whether to love you or hate you. You have made my teaching impossible because now I know my students make mistakes. So I give them one of your tasks. And I see a student making a mistake and I rush over and fix that student's understanding. But by the time I'm done, this student's making a mistake and I rush over and fix that student's understanding. It's impossible. And Malcolm said, that's because you're trying too hard. You don't trust your students enough. If you let your students work together on these problems, for 10 or 15 minutes, which is what the lesson plan says, what you'll discover is the thing you thought was a problem that you wanted to fix. Well, the group talked about that, and that problem got solved. And 90% of the things that you want to fix will be fixed by the other students. So the way we talk about formative assessment is it's the way the environment responds to what the student reveals, not the way the teacher responds. Of course, the teacher is central, but trust the other students to have rich mathematical conversations. We had evaluations of the lessons done, and time after time, one of the things teachers said was, I never knew my students were as smart as they are. They do a lot of the teaching themselves. Once I figured that out, my teaching becomes intervening at important points and supporting their learning. It changes my role as a teacher, and I'm a more powerful teacher because of that. So those are the 5 dimensions. The mathematics, both content and processes, cognitive demand or productive struggle, equitable access to the big ideas and to participation mathematically for every student, providing the opportunity to develop a powerful mathematical sense of self, and all of that is organized and supported by the formative assessment that the teacher puts in place. Okay, so a couple of comments. I mentioned that different countries do things in different ways. We have the Common Core standards in the United States. I suspect you'll recognize that picture. One thing I want to say about that that's very important, because it has to do with the richness of what happens in classrooms. I got my start doing mathematical problem solving. And I spent 20 years working on problem solving. And when people first started doing problem solving in classrooms, what they said was, here is a rule for doing problem solving. I'll give you a problem like, what is the sum of the first n odd numbers? When you see an n, you should try n equals 1, 2, 3, 4, and 5. You will find a pattern, and that's the answer. And then for homework, students had 5 problems just like that. That's not problem solving. That is taking a problem-solving idea and teaching it as algorithmic mathematical content. Problem-solving consists of making progress on problems when you don't know what to do and you don't have the formula for it. And it's very easy to trivialize problem-solving and then remove the sense-making, the conjecturing, the reasoning, the proving. The reason I say that is I'm looking at 8 competencies. It's very easy to trivialize every one of them. And you can think you're teaching the competencies, and instead you're teaching algorithms, and you're not teaching your students to think mathematically. So there's a lot of depth behind those competencies, and it's very easy to convince yourself and your students that you're doing them, when in reality you're not. That's a big thing to worry about. Okay. Whatever you say about the discipline, the point is the other 4 dimensions are critically important. Okay, and they're important in every classroom. So very, very quickly, what can I say about the framework? A few things. First, those 5 dimensions are all you need. Many people will come in and say, do this and your students will learn, do that and your students will learn. If they give you a list of 25 things, you're in trouble. You can't do 25 things. If I give you the list of 25 things, you'll do with what my students do. You'll crumple it up and put it in your backpack. You only need to pay attention to 5 things, and those are the things in the framework. To the degree that those things go well, your students will learn to be powerful thinkers. If there are problems in any one of those dimensions, then there will be problems in the outcome. So you want to get better at all five. There are no rules for getting better at all five. These are deep understandings and they take time. So the serious question is, how do we develop contexts in which teachers can reflect on their work and get better at them? And that's where the key ideas of math leaders or math coaches and professional learning communities are critically important, because when groups of teachers can get together and reflect on these ideas, that's when there can be consistent learning over time. I've been teaching for 50 years, and I'm still not the teacher I want to be. And I still reflect on the way I learn using these five foundations. Second, there's a fundamental shift in perspective. Normally, when a parent visits, when you see a video of a great teacher on YouTube, when a principal visits a classroom, the first question is, did I like what the teacher did? It's the wrong question. Because if you ask who's the most important person in the classroom, parents, principal, and the teacher will say it's the teacher. Every single student will say, it's me. How am I experiencing learning? I'm the one who's supposed to be profiting from the interactions in this classroom. So the key shift in true is to move from, do I like what the teacher is doing, to, what does instruction feel like if you're a student? Imagine yourself being in the next to last row of the classroom, 2 seats away from the window. How are you experiencing what's happening in the classroom? And the important thing is, if you think about the 5 true dimensions, 4 of them are about the student's experience. Okay. So this is probably the most important slide I've ever written, and it's the one thing that I'd want people to take away from any talk or any interview. The question is, what does the lesson look like from the student's perspective? So with regard to the mathematics, from the point of view of the student who's just experienced the classroom, what's the big idea that I learned today, and how does it connect to what I know? Now, I learned this from John Mason. John said, if you want to deflate your ego very fast at the end of an hour's class, ask your students to take 3 minutes to write 2 sentences describing what the lesson was about. When you read their answers, you'll discover that what you said is not what they heard. Okay, so it's really important to think about what it looks like from the student's point of view. Cognitive demand from that student's point of view. How long am I given to think? How do I get to make sense of things? What happens when I get stuck? Do I get to explain things, or does the entire content of student conversations consist of the numerical answers to the problems we were asked to work? Where do I get to do math in a meaningful way? And for every single student, am I one of the people participating actively with the core mathematics, or can I duck under the desk and cover and just hope the teacher won't call on me, and the teacher, knowing that I slow things down, won't call on me? That's a serious problem. So from the point of view of agency, ownership, identity, what opportunities do I have to explain my ideas? In what ways do others build on them? And are there ways in which I'm seen as being able to contribute to the class's mathematical conversations? And finally, formative assessment, again, from the student perspective, where does my thinking go? Does it contribute in meaningful ways to classroom interactions? Respond to what I bring to bear. That's what the student sees. If we can make that better and richer over time, they'll emerge as powerful thinkers. Okay, I think this may be the last one about true. I know lots of people who say, just teach the way I tell you and your students will learn a great deal. They should be on TV between 12 midnight and 2 a.m. selling amazing Ronco mix masters and things like that for your kitchen. That's baloney. Teaching is hard. It's a learned skill. No matter how good you are as a beginner, it takes a good 10 years to really refine your understandings. And I think of the two best teachers I knew. They were radically different. They had styles that were consistent with their personalities. If I told teacher A, teach like teacher B does, it would be a disaster, and vice versa. Each of them had developed their own style, but I can tell you, in their classroom, you could see each of the 5 true dimensions beautifully. So the goal is to grow with your colleagues in ways that you become a richer teacher, which means in ways that you get better at those 5 dimensions. So those 5 dimensions are the principles of powerful instruction. And jargon word problematize, you ask yourself, how do I get better at this one? Can I make the math richer? Can I make the math more accessible so there's more productive struggle? Can I find ways to include more students meaningfully in ways that give them opportunities to contribute more? And can I find better ways of hearing and adjusting? Those are the 5 dimensions in action, problematized. You do that over time, and your teaching will become increasingly powerful, and Bent will have one style, and I will have another. And that's the way it should be. Okay, so in just about 5 minutes, 2 new tools. If we had a week, we spend a week working on these things. So this is just an introduction. You have every right to ask, okay, Alan, you talk a good game. We know lots of academics, they talk a good game. What about reality? What about in the classroom? And the lovely thing about being a professor is that I can choose the 80 hours a week I work, including the 8 to 10 hours a week I spend in classrooms. All of the ideas that I've talked about have been developed in classrooms, in school districts, in partnership with teachers, and refined by them. The true materials are what I call open source. We had original materials that we built, and then we went into classrooms and the teachers said, that's not the way it should be this way. And I said, great, I'll change true. It's got to work in schools. Then what I'd love to be able to do is I spend 3 years on average in a school district. We work together to build the ideas. First, I have to earn your trust. Then we have to work together. And then by the time 3 years are over, you're a community that can do this without me. And I say, it's been lovely working with you. There are other districts that have asked me to work. So invite me back from time to time. I'd love to visit, but I'm going to go elsewhere. There's not enough of me. So my team created 2 books to help schools and school districts do this kind of work without us. What helps, an individual teacher can read this book by themselves, and I hope, learn a great deal. Even better, a community of teachers working on these materials themselves. And if we were live in the first book, which is helping students become powerful mathematical thinkers, if I were in the school We would look at videos, we would problematize them, we would not judge the teachers, but we would ask, here's an interesting thing that just happened in the classroom. What are the various moves the teacher might make, and what are the consequences, and how might they play out? And we would do that over and over again until it became a habit. And we'd start with videos that I brought, because it's very scary to have someone come in and watch your classroom. But then a teacher would volunteer and say, I'm ready. I trust you. I have an issue I want to work through. Can we talk about that? And when that happens, that's when really good, exciting things happen. So I tried to replicate that in the book. We give you a number of tools, but the most important one is case studies, where we say, here's a classroom. I just talked about this. You're part of that kind of learning community. We're videotaping. Let's talk about what happened. So I'm going to go through these slides really fast because I just said that. When you do this as a matter of course, it becomes a way of thinking. Then there's a natural self-improvement process. And the book is trying to do that. So it's a dialogue with teachers. It says, here's a case. Let us tell you about the school we're visiting. Let us tell you about the classroom we're visiting. Let us show you what actually took place, and we'll examine that. Ooh, this student just insulted another student. What do you do about that? Or this student was almost there, but not quite. The teacher walked away without explaining. What are the possible consequences of that? So we go through all of those things. The case will take a group of teachers a couple of weeks to work through. We spend a full day just talking about the mathematics. Then we work through all the detail and ask questions like, why is the math interesting? How can you make it more interesting? Then we look at the tape, or then we look at the transcript very carefully, asking questions about the impact of various conversations on the students. And we ask, what can you say about what the students seem to be learning at the moment? What can we say about both the content and the mathematical practices? How do you think about the way the students were just disrespectful of another student? What do you do about that? We look at all those things, and then at the end we have summary questions that are tied to the 5 dimensions. So tied to the mathematics, where did you see powerful mathematics emerge? How could it have been richer? Tied to cognitive demand, where did you see the students stretched? What do you think about the challenges? Were there the appropriate resources to meet those challenges? There aren't necessarily right or wrong answers, but getting into the space to think about possibilities is critically important. Did you see opportunities for every student to be engaged in a meaningful way? What were the consequences, both for engagement and for the development of mathematical identity? And how was student thinking made public, and how was it reacted to? What might you have done? Do that through all the cases. And discuss them with your peers. You get used to having those conversations. Do that with your peers over your own teaching, and that becomes a way of refining your teaching over time. So my hope for this book is that it catalyzes discussions among teacher learning communities in ways that their conversations get richer so they can help each other become more powerful teachers. Okay. The second book, very, very briefly, is called Mathematics Teaching on Target. The reality is we're stuck with the textbooks we have and the resources we find on the web. Often they're not very good, So the question is, how can we make them richer? Because among other things, the implementation of the true framework depends on having nice, rich tasks that students can talk about. So the question is, we'd like things to be richer along the 5 dimensions, of course. Here's the guiding metaphor that we use. Take an activity. Might be something you pulled off the web. It might be in your textbook. Well, suppose it's okay. It's decent but not exciting. Lands on the target of, yeah, this is something I could use in my classroom. But is it good? But maybe it could be better. Then it lands closer to the center of the target. Or is it really on target? This is one that my students can really sink their teeth into. Well, if you have a task, you can ask the question, can I enhance the task so it moves more toward the center? If I can do that, it'll be richer for my students. So I'm just going to show you in the briefest of ways how the book works. For each dimension, we have some key questions, like for the mathematics, what's the main mathematical idea and how does it develop in the lesson? How do students engage with the content? How do students develop their understandings of mathematical practices like comparing, contrasting, conjecturing, reasoning, etc.? For each of those questions, we have a target. What's the main mathematical idea was the first question. If you can read the things on the outside of the target, and I barely can at this distance from the screen, the things at the very outside are, they're exercises not connected to anything. All the exercises look exactly the same. The ideas don't have applications. The ideas don't connect to big ideas, or the tasks don't connect. If you look at the ideas on the inside, it's, oh, there are connections. There are other things. I could show you the other 2 targets, the same things. Not very rich on the outside, rich on the inside. So take a task. I'll show you one I took off the web. It's a subtraction task. All 20 problems are exactly the same. Well, the numbers are different, but the tasks are the same. In the ones column, the bottom number is larger than the top number, so you have to subtract from the column over. You get so tired that you just do the same thing over and over and over again. Okay, so the question is, how can you make it interesting? Well, if you look at the targets, it's, can we vary the problem type? Can we have students talk about, I've circled the things on the targets that are actually things we can think about. Can we have students talk about different approaches and weigh the merits of those approaches, etc.? So there are ways for each target you can make the mathematics richer, and then after you've done that, you can ask the question, here are all the things that I listed, these I can read. Can you compare and contrast different approaches to the problems? Are there opportunities for strategic thinking? Can students justify their reasoning to each other? Can they compare and contrast alternative methods using evidence? Well, now you can think about modifying the task. They all included borrowing. Why not include some tasks for which you don't have to borrow? So the student goes, whoa, this is a simple problem. They actually have to stop and think. Or one of the problems was 43 minus 19. Ask if someone solved it a different way. At least one student is going to say, 19 is so close to 20. I did 44 minus 20 because that's 24. And then you can ask, are there other times you want to do this? Are there other problems for that? What if I gave you 79 minus 18? Would you want to do that for that? And have the students talk about that. And by those kinds of alterations, the extremely boring tasks become tasks a class can operate with. If we had the time, I would go through lots more tasks. The book has 3 tasks, elementary, middle, and secondary school, for each of the 5 dimensions. And if you get in the habit of doing that, those are just illustrative, by the time you're done, then you have a tool for when you open your textbook or you go to the web and you find a pretty boring task saying, I don't have much time today, but I can take one of these tasks and make it a lot richer, and my class will be better for it. So this book, that tool for enhancing tasks, the first book for making conversations richer, are things that I hope will help teacher learning communities enhance their teaching over time. And I thank you for your patience. Yours too, Bent.
Thank you, Alan. And vi tager lige en kort pause, og vi er tilbage igen om et øjeblik. Og jeg håber, I vil følge med i den diskussion, Alan og jeg har lige her efter det, han har præsenteret. Vi ses lige om et øjeblik. Velkommen tilbage. Jeg vil nu tage en snak med Alan om noget af det, I lige har set på hans slides. Welcome back. I told the participants, and my question will focus on the framework,
Right.
mostly. And one of my question is, when I look to what you are describing, the content as the first framework, you use the word disciplinary. Maybe you should, and you use it two times, I think, the disciplinary thinkers and disciplinary habits of mind. Why the word disciplinary? What's your opinion about it?
Yeah. There are not just different content subjects. There are different ways of thinking. I'm good at mathematics, so I'm not good at physics. I don't think like a physicist. I do some of the things that mathematicians do, conjecturing, particular kind of sense-making that are very typically mathematical. And when you learn mathematics, you learn some of those things. It's like in art. The first time you go to a museum and you see a cubist piece, what is that? I can't make sense of that. But to the artists who studied that, that was a way of representing reality. So, and different artistic generations had different ways of representing reality. In order to understand what they were doing, you needed to understand the way they thought about what they were painting. In the same way, you can become a powerful mathematical thinker and not have that many tools that will help you in chemistry or in literature. But if you don't learn those things, you don't become a powerful mathematical thinker.
But I heard it that you could use the framework in other disciplinary area. So that's why you don't mention mathematical thinking.
When I'm talking about mathematics, mathematical thinking is absolutely central, and everything in that first box, sometimes I call it the content, sometimes I call it mathematics, sometimes I call it the discipline, includes everything about that area, mathematics and mathematical thinking. Now, if you were a Danish teacher, say Danish history, there are also ways, I didn't mention that, of thinking historically that are very important. Well, the framework would then be column number 1, Danish. Column number 2, cognitive demand, equitable access, etc. And the question for you as a Danish teacher would be, what are all the important facts about Danish history, understandings about historical forces, ways of thinking historically that will help my students understand that history. Same for chemistry, same for physics, but the 4 dimensions about the students remain the same.
You mentioned that the content is a wide definition. Maybe you should say it once more. And I ask you for where are problem solving, the children's way of handling it in their working at the classroom and so on. How far do you go when you talk about content? Because I think some teachers could think it as fraction and geometry and so on, but in your mind, I think it's a wider definition.
Yeah, thank you. I told you I had a story about this.
That's why I asked you.
When I published my book, Mathematical Problem Solving, in 1985, it was the right title for the book, but I regretted that, now I'm going to forget his name, British colleague, it'll come to me, titled his book, Thinking Mathematically. Mm-hmm. And I really think thinking mathematically is the appropriate idea because it means looking at the world and seeing it in mathematical terms, deciding when you can represent it. Now, of course, you use your mathematical understandings, but they're part of something bigger. So here's the story. I developed my problem-solving research and I moved to the University of Rochester. And I met with the math department chairman and I said, I want to teach my problem-solving class. And he said, sure. I said, I want to teach it at the lower division level because students don't have an opportunity to think mathematically, and this is what I want to do. He said, fine. He said, the only thing is, I can't give credit toward the math major. Okay. And I said, why? And he said, because you're not teaching content. And I said, oh, yes, I am. There's a unit on Diophantine equations. There's a unit on geometry. There's a unit on this. And he said, no, it's not organized as content. And I said, I'll tell you what. You think I'm arrogant now. You should have seen me then. I'm going to teach my students, whoever I get. My goal is to enable them to solve problems that I have not taught them how to solve. That's the problem-solving goal, okay? You can handpick the same number of your very best math majors, okay? Now, my final exam consists of 3 parts. 1, problems that look like problems that we've solved together. 2, problems I know can be solved by the same methods but don't look like them at all. 3, I went to a problem book, and as soon as I found a problem I didn't know what to do with, I put it on the final exam. Okay? I will bet you my year's salary that my students will outperform your students, your hand-picked math majors. And he said, and this is a direct quote.
He took the chance.
No. He said, I'm sure you're right, but, direct quote, we can't give credit toward the major. You're not teaching content, you're just teaching them how to think. Well, damn it, learning to think is what math instruction should be about. And that's a large part of Dimension 1.
Yes, thank you very much. I will go on with your cognitive demands. And when I discuss the thinking of challenge the children in the classroom in a proper way, so it's not too heavy as you told, as your analogy, and not too heavy and not too very easy to handle. I have heard teacher mention for me that there are children in the classroom who struggle with life, who struggle with themselves, struggle with the environment, struggle with the parents, and so on. So why give them struggle and challenges in math class? Why not just give them easy adding and they will sit calm and maybe a little bit happy because there are no struggling? what will you tell the teacher?
That's such a sad perspective.
Yeah, maybe.
What you have to remember is all 5 dimensions. One of them has to do with the student's identity. So the question is, what are the short and long-term impacts of that decision to, quote, be kind to the student? In the short run, the student may well feel, okay, at least I don't have to struggle. I can take a nap today. That's better than otherwise. In the long run, when you think about identity, okay, the teacher knows I'm stupid and treats me like that. That's why I hate school. That's why I'm not going to use my thinking anywhere. How am I going to be a productive citizen if that's the way I think of myself? And it's the teacher's fault because it's very clear the teacher doesn't respect me. Okay, so I think that's one of the ways in which trying to be kind backfires. Now, the teacher then has the right to say to me, that's easy for you to say. You're not dealing with a classroom in which there are these students with all these different abilities. And my response to that is, well, actually, I live in classrooms, but you're right. It's an extremely difficult thing, especially if you have a narrow curriculum. Because if you have a curriculum with a certain level of tasks, then 1/3 will be happy, 1/3 will be lost, and 1/3 will be bored. So the problem is to develop tasks that are, interestingly, paradoxically, richer mathematically, that allow more students to do them.
So you have also used the word productive struggle.
Yeah.
What do you mean about productive struggle?
If I gave the students who built the tables the algebra problem, they might manage, they'd probably write some random equations, they might get the right one. They wouldn't remember it. They wouldn't learn anything. They struggled, but nothing would have come out of it. In this example, they started with what they knew, and they made connections, ultimately seeing the algebra as the sensible way to represent what they had done. That was productive.
Okay, yeah. So there are some. It's not concrete, but productive.
Yeah.
But there are some concrete elements in it.
Yeah. Well, you start with what you know. And if I were talking jargon, I'd mention the zone of proximal development by Vygotsky.
Okay, yes.
And you build on what you know in ways that make that part of your understanding. That's what makes the struggle productive.
I have another question for you about equitable access to content. My thought was, when we discuss equitable, I think many of Danish teachers think inclusion.
Yeah.
Could you use some words about the connection between the inclusion discussion and the equitable discussion?
Yeah. I've visited many classrooms where, let me talk about, in the U.S., 7th or 8th grade, factoring simple quadratic equations, x squared plus 10x plus 24. Okay. I already figured out that's x plus 6 times x plus 4. I'm in the fast group. Okay. There are some students, in order to be able to do that task, you need to be able to factor 24. In lots of different ways. There's 3 times 8, 2 times 12, 1 times 24, 6 times 4 was the one that worked. Okay. In a widely diverse class, there would be some students who have real trouble factoring. So what this teacher did was she separated the class in 2, and one part of the class spent the time factoring 24. The others did the algebra. Well, guess what? At the end of the class, these students the ones who factored 24, never engaged with the algebra.
Okay.
They were included in the class, but that was not equitable.
Okay. But not including the content in somehow.
Yeah, they have to be included with the core mathematics. If they're not, they're not learning the mathematics. And there are many examples of how in classes where that happened, at the beginning, one group of students is here, another group of students is here, there is a distance between them. At the end of the year, they're further apart because the ones who were just included learned so much less. They didn't even have the opportunity to learn.
But the main discussions in then to have good tasks for the children.
Absolutely.
And where do we find the good tasks for the teachers? Because it's not easy to create good tasks.
Yeah. Well, I have two answers to that. The first is there are people who have devoted their lives to things like that.
Yeah.
And my favorite example is the set of tasks from the Shell Center at Nottingham. Yeah. If you go to the web and you look for Mathematics Assessment Project Shell Center.
They have good tasks.
Yeah, they have, they have gorgeous tasks. And they also have the formative assessment lessons. The team under Malcolm Swan's guidance built those. The tasks in those lessons are among the most beautiful tasks I've ever seen. So there are 100 lessons, there are loads of good tasks, there are assessments. Now the second thing is my second book. On Target.
Read it.
Read it, yeah. I mean, most of the tasks we see are pretty lousy, and that book says, here's how you can make them better.
Okay. I have the final question, because we have to end up the webinar. Some are looking and listening to what we have talked together out in the teacher community in the classroom. What could you recommend for going on with your thought after have seen this and have a discussion in the team?
Yeah. I should preface it by saying teaching is hard. People don't recognize what a challenge it is. They often have simple solutions. They don't work. When you begin as a teacher, you may be very talented, but it's going to take years, even with support, to evolve into someone who is truly knowledgeable, can truly create environments that support all students in the right way. You need tools for that. In the best of all possible worlds, you need collegial support. I can't tell you how many times I taught a class and went home, that didn't go the way I wanted. I screwed up here. I should have done this differently. It's because, and how do I fix that? Well, I know the 5 dimensions, and I can identify the ways in which it didn't go well and think about it. The task wasn't rich enough. So one thing is, if you learn to think with the ideas in the true framework, it becomes a way of improving. The person who is in charge of the schools in the city of Chicago in the U.S. told me when they started using True, one of the big differences was her 2nd grade teachers could talk to her 6th grade teachers who could talk to their principals because they all had the same language for talking about what happened in the classroom and how to improve it. Now, what I'd like to see is professional learning communities, and that's a beautiful thing about Denmark because you have them and you have lead teachers or coaches to help with that. When I work with school districts, we start with me introducing the ideas and using videotapes from elsewhere. Because being seen on a videotape and having your colleagues comment is scary. After a month or two, they say, okay, Alan, we trust you. It's a safe environment. And then a teacher will say, I have a problem, okay? And we'll work on it. Now, I can't be everywhere. That's why I wrote the first book. If a teacher-learning community works through the cases in that, develops the habits of questioning, then they have a set of tools that they can use for their own teaching, and then it's a self-sustaining process.
Thank you very much, Alan. Og også til jer. Vi kommer igen på et senere tidspunkt med et nyt webinar. Kan I have det godt derude.